Hello, so this is a revision video for AP Chemistry 1.6, Photoelectron Spectroscopy. Photoelectron spectroscopy, or PES, measures the energy needed to remove electrons from different subshells in an atom. Specifically, it measures the binding energy of electrons, the energy required to remove an electron from a specific orbital. Electrons that are closer to the nucleus are more strongly attracted to it and therefore require more energy to remove, having a greater binding energy. The data from photoelectron spectroscopy is often presented as a photoelectron spectrum, a graph, with the x-axis being binding energy in megajoules per mole or electron volts, and the y-axis being relative number of electrons. Each peak represents electrons being removed from a specific subshell. The relative heights of the peak show how many electrons are in that subshell, and the position of the peak, so how far on the x-axis it is, shows how strongly the electrons are attracted to the nucleus of the atom. The further right on the x-axis the peak is, the less attraction it has to the nucleus, meaning the subshell is further from the nucleus of the atom. A PES spectra can be directly linked to electron configurations. Each group of peaks matches the electrons in different subshells. For example, an unknown element X has a PES spectrum with the following features. By looking at the relative number of electrons from the peak heights, we can see that the first two peaks each refer to 2 electrons being removed, and the biggest peak, 5 electrons. Well, the first peak must be a 1s, the second peak must be from a 2s, and the final peak must be from 2p, meaning 2 electrons in the 1s, 2 electrons in the 2s, and 5 electrons in the 2p. This would give 9 electrons in total, which would correspond to the atomic number of fluorine, meaning the unknown element is fluorine. Exam tip here: in PES questions, be ready to match spectra to electron configurations or explain differences in binding energy. Focus on how close electrons are to the nucleus and how many occupy each subshell. Also remember that the x-axis is binding energy, it decreases to the right.